Welcome guys, in today's tutorial I'm going to cover the concept of unions and Bitfields. But first, as most of you guys know, the instructors usually cover the data type known as structs in almost every programming class. So we're going to first explore I'm pretty sure all of you guys know what a struct means. A struct is basically a data type in which there are fields, and each field occupies a certain bit of memory, occupies a certain space in memory. And so you can think of it as like a class in a higher programming language without the methods or functions in them. So we're going to explore other two data types known as unions and Bitfields. So let's just jump right into it. So basically, a struct, like I mentioned earlier, has fields in which each field occupies a certain space in memory. But say you want to represent, so in this case I represent a quantity fruit which has a count, weight, and volume. Say I want to represent a quantity, right? And a quantity could either be count, could either be weight, could either be volume. In that case, I want each of the fields to occupy or share the same space in memory. So in that case, I represent, instead of struct, I represent the data type by a union, and I could just call this quantity. If you guys want to think of it in terms of Boolean logic, you can think of structs as an intersection of all the fields, and a union, quantity as, a union as union in Boolean algebra. So a struct is an intersection, union is a union in Boolean algebra. So that's basically the idea, is that if I want these fields to share the same space in memory, then I can use a union. And you can put a union inside a struct inside a union. Like you can use it in however way you want it, but this is a convenient feature to have if you want the data type to share the same space. If you want the fields to share the same space, one application of this would be, like I mentioned here, if you want to represent, say, quantity, as it could be either count, weight, or volume, all these stuff indicate a quantity, you can represent that by union. And what you can basically do then is, like I mentioned earlier, you can put the union inside a struct. And for example, if you have a fruit order, then you can represent the quantity. You can put the union inside the struct and represent that by basically a fruit order. So another application of where you want to use union is, say you're packing and unpacking IP addresses. In that case, what you want to do is each subnet, whatever, I forgot the exact term they call it, but say you have a 32-bit IP address, and each component is 8 bits, so you have something dot something dot something dot something. Like for example, if you have 192.18.1.1 or whatever, so each part is 8 bits, and together they form a 32-bit. So you can just represent it by a union with. You can represent by struct within a union in which each component is 8 bits. So in that case, the individual objects, when combined, share the same space as the entire object combined together. So what I mean by that is each individual thing, like 8 bits, 8 bits, 8 bits, they all combine to form 32-bit, is the same thing as entire object being 32-bit. So in that case, you would want to use unions too. So basically, the idea is that you want to use unions whenever you want the fields to share the same space as the entire quantity. And so that's just a convenient feature to have. The next feature I want to introduce is a feature known as Bitfields. Bitfields aren't really used that much, but I'm just putting it out there because it's a really convenient feature to have. It's just convenient to know. So what a Bitfield basically is fields which have certain bits in them. So what I mean by that is, say you're constructing a synthesizer, so you're simulating a synthesizer, and so this is a synthesizer, and then you want the do want the synthesizer to have options in which you want to say one option is on, one option is off, and you want to have series of that. You want to model that basically. So in this case, I have a struct with synthesizer, and I have so the different options are the low pass and the high pass filter, reverb, sequential, and stuff like that, and it keeps on going. So you want to model a synthesizer with different fields in which you have each field is on or off, and you want to have, like, say, a series of them, like maybe 60, maybe 100, and then if you want to really save space, use the Bitfields. So in order to use Bitfields, notice the strange syntax declaration here. I'm pretty sure you guys have never seen this, but the syntax, at least the syntax for this. So the syntax for this is very simple. You just say the field and you put a colon next to it, and you say how many bits you want to represent that. So I want to represent the low pass filter by 1 bit. I want to represent the filter coupler by 1 bit. I want to represent the reverb by 1 bit, and so on. So 1 bit in this case says it's true or false. So basically, say in some other thing, say in a calendar or whatever, so say you have a typed struct, and in that, if you're representing a calendar and you want to represent the days of the week, so that's 7 days. So you want to represent that by 3 bits. So in that case, you would just put 3. I mean, today Bitfields aren't used a lot because space isn't really an issue. This really applies if you want to save space. Another application of Bitfields is if you want to read and write off a custom binary file, you can use Bitfields. It's just similar, really similar to Struct, except each field can be controlled in terms of how many bits you want to use for that field. And that's pretty much it. So we basically saw the difference between a union and a struct and Bitfields and the other type. Basically, we explored the other data types besides structs, such as unions and Bitfields. And these are just features to have. It isn't really used much, but I thought I would just cover it because, just to have it in your tool. So hope this video helps. And thanks for watching.